Okay, in this video, let's take a look at how to graph a cosecant function, which is stretched or shifted. In this case, it's a secant function. It says graph one period of y equals 4 secant pi over 3x minus pi over 2 plus 1. So what I recommend is start by graphing the corresponding cosine function, right? Secant is 1 over cosine. So start by graphing the corresponding cosine function. So you're going to graph y equals 4 cosine pi over 2 without the vertical shift yet. Okay. Not a shifted graph. We're gonna 1 unit. All right. Okay. So let's figure out what our parameters are. Let's graph one period of this graph first. And so our period is 6, right? So it would have been from 0 in a positive direction, right? It's negative, so we change the negative to positive. So it's the shift is 3/2 in the positive direction. So, and 3/2 is 1.5. So we're gonna add 1.5 on both sides of the where the beginning and the end of the period. So we have the period from 1.5 to 7.5. That's let's graph this cosine function. So the beginning of the period is 1.5, and that's where the cosine is the has its maximum. And what is the maximum? We know that a is 4, so it's stretched by a factor of 4. So it's we're gonna plot the point 1.54. Right there. And then it also is reaching its maximum at 7.5. So it goes to 4 as well. At that point, okay. It has its minimum in the midway between these 2 points. In general, the most important points in the period are the beginning, the end, the middle, and the quarter points. So let's figure out those points. So the middle between 1.5 and 7.5 is going to be, we have 8, 9, 4.5. So 4.5 is a center point, and the function value has its minimum. The cosine has its minimum. Now, where does this cosine crosses the x-axis? Well, the first cross is between 1.5 and 4.5. So 1.5 plus 4.5 over 2. So that's 3. It's going to cross here. And the second one is between 4.5 and 7.5, the second cross. So we have 4.5 plus 7.5 divided by 2. It's going to be 8, 12 divided by 2, 6. Okay, here we go. So this is what my graph of this cosine function is going to look like. This is just one period of that graph, and we're going to extend it in both directions. So that's 3 here, so 2, 3 is gonna cross again. Okay, and again, no, here. Okay, so here's our graph. Now, what about, but that's full cosine of this function, right? Of this angle. Now we need a secant. So we're gonna, for the secant function, we're gonna draw our asymptotes like so. So we're gonna draw. Now, remember that we will have to move our graph up by 1 unit. So I don't want to do it in hard pen right now, but so I'm gonna again draw kind of like a guide that which I'm gonna move up. So there you go. And now from this point on, I can move these up. So up by 1 unit. Now this is going to be the graph of the secant function. 1 up like this, 1 up. So now this is the graph of my secant function. Now, what do you do if you're given a graph of the cosine function like this, and you're asked to sketch a graph of a secant function? All right, so first of all, you're gonna find the midline for this cosine of a graph. So here the minimum is -1, the maximum is 3. So the midline is obviously gonna go through +1. Now you're gonna see where your graph crosses the midline, and that those are gonna be your asymptotes. So you're gonna draw asymptotes through those points of intersection. And from here on, you're gonna do the same thing that we did. So up to this point, just draw a function that would touch the minimums and maximums of the cosine graph and go in the opposite direction along the asymptotes. And our last example in this section, we're gonna sketch a graph of y equals 2 cosecant pi over 2x plus 1. Oh, it's just asking what are the domain and range of this function? Well, after we graph it. Okay, so let's begin. We're gonna graph the companion function or the guide function, which is a sine function, right? So it's going to be y equals 2 sine pi over 2x without moving it up or down yet. All right, so the amplitude of this function is 2. The b is pi over 2, and that means that the period of this function is going to be 2 pi divided by pi over 2, which is going to be 4. There is no phase shift, so our x is going to be between 0 and 4. So this is literally going to be the beginning and the end of one function cycle. So let's sketch. All right, here we go. So sine is 0 at 0, and it's again 0 at the end, and it also is 0 in the middle, and then it reaches its maximum a quarter way into the period, which the maximum here is going to be 2, and the minimum is going to be a -2. So this is one period of this function, and we're gonna actually extend it, right, to let's extend it in both directions. All right. There you go. Okay. So we are actually ready to draw asymptotes. So they're gonna go through 0, 2, 4, 6, 8, so forth, -2 as well. Now, for the guide for our cosecant function, remember we're gonna again move it up by 1. So this is the guide. And now let's move it up. So where 3 is, go up and up, and here down, down, and down. And this is the final graph of my cosecant function, the one in dark purple. Now, the question is, what are the domain and range of this function? So we could tell from the graph that the domains will exclude -2, 0, 2, 4, 6, and 8, and so forth in both. So the domain of this function is going to be x not equal to 2k. So the even number, where k could be 1, 2, 3, or any whole number. Now, what about the range? Well, we can see that the upper portion of the graph is above this line, which is y equals 3, and below this line, which is y equals -1. So it's below -1. The range is from -infinity to -1, not including infinity, including 1, -1. And then it picks up from positive 3 to infinity. 3 to infinity. So this is the domain and range of this. In general, if you need to write the domain and range of this function, you're gonna find that domain in this